Okay, 7.3, factor a difference of squares. So difference of squares, a binomial in which a square term is subtracted from another square term. And we're going to get into what that actually looks like. Okay, so the factors of a difference of squares are binomials, okay, with identical terms, but opposite operations. Okay, a difference of squares is a binomial with square terms as the first and second terms, separated by a subtraction sign. Okay, so in other words, when we take a look at this, what this means is the factors are binomials. So if we look down here, here's the example. Okay, so it is a plus b, so that's a binomial, two terms. And then a minus b, that's a binomial, two terms. Okay, and they're separated by one has a plus sign and one has a minus sign, right? Opposite operations. Okay, when that's actually expanded, we get this. A term squared minus a term squared. And that's what this bullet means. Okay, the factors of a difference of squares are two binomials right here. In one binomial, the factor of the square roots of each term is the difference of squares are added, and the other one, they're subtracted. Okay, so again, it's just when we root a squared, we get a. Okay, and when we root b squared, we get b. A minus b, a plus b are these two factors. Okay, so let's start from the basics. Example 1, write the positive square root of each. So if we root 9, the answer is 3. If we root 25, the answer is 5. Okay, as a recall, 3 times 3 equals 9, so square root of 9 is 3. 5 times 5 equals 25, square root of 25 is 5. Okay, the square root of x squared is x, and the square root of 4x squared is 2x, right? Because we're rooting 4 and then we're rooting x squared as well. Okay, example 2, write each number as a power of its positive square root. So 16 can also be expressed as 4 squared, right? Because when we root it, we get 4, and we know 16 is going to be that 4 times 4. 9 can be expressed as 3 squared, which is like 3 times 3. Okay, example 3, which expressions are difference of squares and how do we know? So in A, we have two terms, okay, so that's good. We can root the first and we can root the last, okay, so root both. And there's a minus sign. Those are the three conditions of difference of squares. So yes, difference of squares, DOS. Okay, B, there are two terms. We can root both, right? Because we can root x squared is just x and root 16 is just 4. Okay, but there's a plus sign. Plus sign. Therefore, not difference of squares because of that plus sign. Okay, in C, there are two terms. Okay, we can root both. We can root 1 and we can root 49 and we can root x squared, right? So root both. And this is a minus sign here. Minus. So yes, therefore difference of squares. Okay, and then D. We can root the first and the second. There are two terms. So two terms, root both. Okay, but there's a plus sign. Okay, and because of that, no, not difference of squares. Okay, example 4. Factor each difference of squares. Check your answers by expanding. So, for A, what we're going to do is we're going to take the root of x squared. So what is root of x squared? I get x. Okay, we're going to take the root of 36, and I get 6. So we're going to use these two terms, and that's going to be our binomials. X plus 6, x minus 6. Okay, and if we were to take it down here, and we want to check our answer by expanding, well, we would just have to go x times x is x squared, x times negative 6 is negative 6x, 6 times x is positive 6x, and 6 times negative 6 is negative 36. Those middle terms cancel out because they're the same, and we have x squared minus 36. Okay, B. We're going to root 9, which is 3, and we're going to root x squared, which is x, and now we're going to sub in 3 plus x, 3 minus x. And that's it. If we wanted to check it, we would come down here and we would FOIL these two brackets. 3 times 3 is 9, 3 times negative x is negative 3x, 3 times x is positive 3x, and x times negative x is negative x squared. These two middle terms cancel out. Every single time with difference of squares, those two middle terms will cancel out, and we get 9 minus x squared. Okay, so let's go ahead and root these two terms. So 16x squared, how we're going to treat this is, what is root 16? Well, it's 4. And what is root of x squared? It's x. So the root of 16x squared is the 4x. Okay, we're going to root 81, and we get 9. And we're just going to take these two terms, and we're going to put them in the two brackets, one with a plus sign, one with a minus sign. So I get 4x plus 9 and 4x minus 9. And that's it. That's done. It's factored. Okay, if you want to go ahead and re-expand this, we're going to get 16x squared plus, what is 4x times negative 9? I gotta go back. Negative 36x plus 36x, which is 9 times 4x, and then minus 81. Again, difference of squares, these two middle terms will always cancel out, and I'm left with 16x squared minus 81. Okay, last one. We're going to root 4x squared, and we're going to root 1. Root of 4 is 2, root of x squared is x, root of 1 is 1. Okay, so we get 2x plus 1, 2x minus 1. Right, take those two terms are the terms in your binomials. So if we wanted to go ahead and check our answer, 2x times 2x is 4x squared, 2x times negative 1 is negative 2x, 1 times 2x is positive 2x, and 1 times negative 1 is negative 1. Okay, we can cancel out minus 2x and plus 2x, and we get 4x squared minus 1. Okay, last example, example 5, the area of a table can be modeled using this equation, okay, with the area in square meters. Find the expressions for the length and width by factoring the equation for area. Okay, so we're going to start with the equation for area, and we know that this is difference of squares because there are two terms, you can root both, and there's a minus sign. So let's root x squared, and we get x. Let's root 16, and we get 4. Okay, so our area expression is x plus 4, x minus 4. That means our length is going to be one of these. Let's just call it x plus 4, right? Length and width are interchangeable, and width is x minus 4. Okay, B, use your answer from A to find the area if x equals 15. Okay, so let's go. The length will be 15 plus 4, which is 19. The width is going to be 15 minus 4, which is 11. So the area is going to be 19 times 11, which we get 209 centimeters squared. And what we can do for C, we can check by substituting it in to the original equation. So if we subbed in for x squared minus 16, we subbed in the 15 there for the x, what we're actually going to get is 225 minus 16. We're still going to get that 209 centimeters squared. And if you want, you can put therefore the area when x equals 15 centimeters is 209 centimeters squared.